Adding fractions. So remember that when we're adding, we're really counting more of the same thing. So if I look in the first example, it says 2/3 plus 1/9. So here I have thirds and then I have ninths, and those are not the same thing. So if I want to add these, I'm going to have to make them have the same denominator so I can count the same things. The idea is that if I want a common denominator between 3 and 9, one way to do it is to find multiples of 3 and 9. But before we do that, one thing we want to check is when I look at my smaller denominator 3 and my larger denominator 9, I can ask myself, is 3 times something equal to 9? And it is. 3 times 3 is equal to 9. Now I have to remember that whatever I do to the denominator, I have to do to the numerator as well. So I'm going to have to multiply that 2 by 3 as well. That's going to give me 2 times 3 is 6 over 3 times 3 is 9 plus 1/9. So now I can see that I have the same thing. I've got 6/9 and I want to add to that 1/9. Well, if I have 6/9 plus 1 more 9th, that gives me 7/9. In the second one, I have 1/4 plus 5/6. So I want to find the common denominator between 4 and 6 so I can count the same things. So I can look at 4 and 6 and just count by 4s and 6s. We'll find multiples of 4. So the first one would be 4, and then 4 more is 8, and then 4 more is 12. And let's just do one more. So 4 more than 12 is 16. Then if I count by 6s, I get 6, and then 6 more is 12. So we can see that the first multiple that they have in common is 12. So now I can say 4 times what is 12? Well, it's the 1, 2, 3. It's the third multiple. So 4 times 3 is 12. And whatever I do to the denominator, I have to do to the numerator. For 6, 6 times, well, we count them, and it's 1, 2. So 6 times 2 is 12, and whatever I do to the denominator, I have to do to the numerator. So that gives me 1 times 3 is 3, and 4 times 3 is 12, plus 5 times 2 is 10, and then 6 times 2 is 12. Well, we know that now we're counting twelfths. We have 3/12 plus 10 more twelfths. So when we're done, we're going to have 3 plus 10. That's a total of 13/12. This kind of fraction is called improper. So what we notice is that each whole is divided into 12 pieces. So I can have 12/12 plus, to get a total of 13/12, I would need one more 12th. And I always like to look at it again. 12 plus 1 is my original 13. And then 12/12 is one whole. So I have 1 plus 1/12. And by definition, that's the mixed number 1 and 1/12. In the second one, or the third one, first thing I want to note is that I've got a negative plus a negative. Okay? So when we're adding and we have the same sign, we know that we add and keep the sign. So my answer, if I write it off to the side, since it's a negative plus a negative, I know I'm going to get a negative. And then what I would do is just rewrite my numbers and disregard their signs. So 4 over 9 plus 1 over 6. Knowing that my final answer is going to be negative. And then I would count by 9s and 6s. So if I count by 9s, I get 9, and then 9 more is 18. 9 more than that is 27. And then for 6, I'd have 6, and then 6 more than that is 12. and then adding 6 to 12 I get 18. And I can stop because they have a common factor of 18. So then I say 9 times what is 18? Well, it's the 1, 2. It's the second factor of 9, so 9 times 2 is 18. Whatever I do to the denominator, I must also do to the numerator. Now 6 times what is 18? Well, it's the 1, 2, 3. Third multiple, so 6 times 3 is 18. Whatever I do to the denominator, I have to do to the numerator. That's going to give me 4 times 2 is 8, over 9 times 2 is 18, plus 1 times 3 is 3, over 6 times 3 is 18. When I add, I've got 8 plus 3 is 11. So I have 11 over 18. What that's telling me is that if I have 8 18ths plus 3 more 18ths, that's a total of 11 18ths. Now I know that when I look at my answer, it says that my answer should be negative. So instead of 11 18ths, we have negative 11 18ths. And so I highly suggest looking at your signs at the beginning. That way we don't get confused. So once again, if I look at my last example, I have 3/5 plus negative 2/3. Since I have signs involved, might as well write my answer off to the side. Now, when I have a sign involved, I have to be careful because I don't know what the sign will be until I get my common denominator. Remember, when we have different signs, we subtract and we keep the sign of the number with the larger magnitude. So the first thing I have to do is look at my denominators. I have a denominator of 5 and a denominator of 3. So first let's count by 5s. 5, 10, 15, 20, and so on. And then we'll count by 3s. 3, 6, 9, 12, 15. So the common denominator will be 15. 5 times what is 15? Well, 1, 2, 3. So 5 times 3 is 15. Whatever I do to the denominator, I have to do to the numerator. And then 3 times what is 15? 1, 2, 3, 4, 5. Whatever I do to the denominator, I have to do to the numerator. So that'll give me 3 times 3 is 9, over 5 times 3 is 15, plus negative 2 times 5 is 10, over 3 times 5 is 15. Well, I know that my answer will have a denominator of 15, because I'm counting 15ths. 9 plus negative 10. So the first thing I do is I subtract, and I would just say 10 minus 9 is 1. Next I have to keep the sign of the number with the larger magnitude, and 10 has a larger magnitude than 9. So, and the 10 is negative, so my answer is negative. So we get negative 1 over 15.